Hi, welcome to Mill Savvy Tutorials. I'm Luke, and today I wanted to talk about chamfering using mill profile and area machining on OneCNC. Chamfering on any CAD CAM can be either really easy or really hard, and it depends what you're trying to do. A lot of the time, you'll send a program out and it won't use comp when it's chamfering, and obviously you're removing a little bit of control, from the guys on the shop floor. For example, you could argue that there's what I'm about to say. There's better ways of doing it, and how you're doing it is old-fashioned or whatever. But then you don't have to listen, do you? But I'm going to tell you the way I use it, and I feel like this again gives the guys a bit of control at the panel. If there is no chamfer, if they need to drop it, if they need to make it heavier, and without need, because not in all cases you can just drop the height of the tool. For instance, like say I was deburring this edge here, and I was literally laying off this face by 0.1 to deburr it, then they're not going to be able to drop that spot drill or chamfer mill, whatever you're using to do this edge here, because you're going to then gouge into here. But if you use compensation, you can just take a little bit off your radius, or if you're using diameter as your offset, take a little bit off that, and it will move that way rather than this way. And that's why I do it for examples like that, where you're doing something that you're already right close to the edge and you can't really afford to drop that tool. So these are 0.5 chamfers, and I use the mill profile command, but what I do is I model up my tool as like a little 1 diameter. This is a 3 diameter tool. I put so in my notes so I know when I post the program out what offset it needs, what tool I'm using. It simulates it with a 1 mil, so the simulation is not going to match up perfectly to what you're going to see, but you do have to apply a little bit of logic to this. But this is how you get it to work with comp. So anyway, I set this tool up in my tool library. I just name it 3 mil spot with a 0.5 offset, and then set the diameter to 1. Stick out holder. That's up to you what you have there. And then it is a bit notorious with with any spot drill, depending on what brand you buy, depending on if you're using high-speed steel, carbide, whatever it is, the quality of them vary, and some of them don't go to an exact point, because obviously if they go to an exact point, that point will be weakened when it comes to centering holes. So for instance, I haven't gone 1 mil. That's why you'll see 0.5 offset. Technically speaking, if you go 0.5 deep, you'll get a break edge. If you go 1 mil deep, you'll get a 0.5 chamfer. That's me just trying to justify why I've gone 0.8. Not all tools are going to cut perfectly or simulate exactly what they actually do, what they should do. But in the real world, that chamfer's going to be a bit big. So I've allowed for that. At the end of the day, I can always come back and flick this down to 0.9 to 1 mil. I'd rather go a little bit shy, do it, and adjust it. There's no point risking it, scrapping the part. You may as well, think twice, cut once, get it right first time. That sort of method. None of this is really relevant on here. The only thing that is relevant is that, and if you used to put like the remove amount, but that's not ticked, so I want that as 0. I don't want any of this. I don't want none of this. Don't want none of this. So obviously I want this on, bottom only, and I want at control, which is G41. So it's climb mill, and it's going to offset to the left in the direction that it travels. Now go next. Again, when I'm doing stuff around the top here, where I've got lots of space to play with, none of this is that critical either. This is going to come on in a straight line at a 5-degree angle, 5 mil long, and then it's going to come off in a straight line at 5 mil long as well, because it's doing that here. There's your on, there's your off. You can see there, look, what it's doing. Coming in on a straight line, going around this way, coming off on a straight line. Lovely little jump. And it's going to lift up, move and do all the other pads, and then it's going to drop in and do this. Now this is where you have to be a little bit more careful with how you draw this tool path, and you can see I've done the 90-degree approach so I can control, and I've laid off this wall by a known amount. And then what I do is I come in with the area machining and I blend this in. I blend my chamfer in. I can touch here, can't I? Go along this line and then come round this and chamfer all this. I know I can do that, but I can't get the tool right up against this edge. I could work it out, and I could probably get really, really close without hitting here, but this is why you don't you don't have to try and be smart when you use this sort of software. You can let it do the hard work for you. I've just extruded a cut through my model to create these 3 sections. That's all I've done. Is I've drawn this cube here. I've gone in here, extrude cut, slice my model into 3 parts. Obviously my model, I've called it stock to simulate it, but that's my model. And then I'll remove this, and then it leaves me these to select. If I don't cut it in, I can't. If you look at the area machining, for instance, if I highlight that there, it's going to select that whole bit on the model that I'll show you. Stock, turn that off, go area machining, look, it selects that whole edge. And I don't want to machine, lucky for me, I mean you could do that, but I don't want to machine, you know, 70% of that. I only want to machine this bit here, and that's what it's about. You don't want to waste time, you know, sending your ball nose up and down here, blending this chamfering with something that's already been done. That's not, you know, you're not streamlining your process there. You may as well just, you know, do what I did, extreme cut, and do the one bit that you can't reach with your spot drill or your chamfer or whatever you're using. That's why I did that. It's about, you know, keep that runtime down, keep it efficient. Don't waste time cutting fresh air. No one likes to, you know, if you're the operator of the machine, you see that and go, oh, that's naff that. You know, so just to simulate this, to give you an idea, look, I think I might have done this at the beginning of the video, but I've been waffling on now, so I forgot. But yeah, you can see what it's doing. Speed this up. But now that's been explained. Look, deburr, can't get in the corners, no problem. So obviously it comes in surface machines that. Does them bits there as well to blend that. And then just does them corners. And that'll get, the beauty of area machine is it works it out to the model. So it knows what tool you're using, it can see the model, and you'll say selecting that edge there, so it knows that that tool needs to lay off this wall by whatever the number is to not, you know, not collide with it. I think if you look in my settings, I think I think it's an 05 finish allowance. Yeah, look, leave the finish in 05. That's me controlling how much I want it to lean off that wall. If I left that to 0, then the shank of the tool might touch that wall. It's likely it's going to, and you're going to get a bit of shank rub. Right, it's not going to gouge. In full fairness, it'd be so slight that you could probably scotch it out or something. But you don't want to be doing stuff like that. You want the machine to do all the work for you, finishing stuff outside of the machine, and you're not really getting your, you know, value for money, are you? You pay all that money for a machine, get the machine, and your CAD package to do all the thinking for you. But like I say, this channel is here to show things like this. If you do watch OneCNC Tip of the Day, you know, from them guys there, I mean, they do a fantastic job. There's loads of really good advice there. All I'm trying to offer differently to that is, from a user's point of view, in the day-to-day use. I mean, the video is going to be slightly longer than theirs, and just go into depth on how you do things like this and do things that people want to see. This is something obviously I've modelled up from a job I've done in the past, so it's not exactly the same, but yeah, let me know what you guys want to see. I do want to do a video on how I've manipulated my posts, because this is a little bit confusing, and something confuses me. But you know, I've worked it out. I've sort of worked out how to get by in it. I'm no expert in here. I don't claim to know everything there is about to know about OneCNC, because I definitely don't. But I know how to get by on it, and that's what I want to show people. So anyway, let me know what you guys want to see. Thanks for watching.